Today I'm going to be showing you a side-by-side comparison of two division strategies. On the left-hand side I'm going to be showing you partial quotients, which is kind of a new way of division. Maybe you're not used to seeing numbers being divided this way, and I'm going to explain how it relates to the right side, which is the traditional method. So we're going to get started, and I'm going to show you how to solve using partial quotients, because that's what I'm teaching students in class, because it emphasizes the number sense. It emphasizes why certain numbers equal what they do, because sometimes we lose that when we're using traditional method. So we have the division problem 234 divided by 6. So the first thing I get people to ask themselves is, how many times can 6 go into 234? So you're thinking about the whole number, 234. How many times can 6 go into that? Well, sometimes you can think of that mentally, but I have students use a visual which is called a cheat sheet. So they think about all the times of groups of 6 that you can make. So you can make one group of 6, 2 groups of 6, 5 groups of 6, which is 30, 10 groups of 6, which is 60, 20 groups of 6, which is 120, 50 groups of 6, and 100 groups of 6. So we kind of use this to compare. So how many times can 6 go into 234? Well, we have over here 20 groups of 6 can go in 120 times. But this jumps from 20 to 50. So we can brainstorm that 30 times 6 is 180. And that can go into 6. So we're going to use 30. We want to take away the biggest chunks that we can and subtract it out, because that's what division is repeated subtraction. So we're going to take out 30 groups of 6. So 30 groups of 6 equals 180. So we're going to do that and subtract. 4 minus 0 is 4. 8 minus 3 I can't do without borrowing. 13 minus 8 is 5. 1 minus 1 is 0. So now I ask myself, how many times can 6 go into 54? And I can continue to use this, or I can use my multiplication chart, because this should be a quick fact. So I go down 6 to find 54. My other factor is 9. So 6 can go into 54 9 times. And we subtract that out. So when we subtract 54 minus 54, we get 0. Yay! And we're happy, because that's what we want to get to. We want to get to our zeros down below. Now when we're done, over to the side we have our partial quotients. This is what we have to add together to get our final answer of 39. And we emphasize lining the place value up here. So we can now check it. 39 times 6. Okay? 6 times 9 is 54. Carry my 5. 6 times 3 is 18. 19, 20, 21, 22, 23. So we get back to our original dividend for our multiplication problem. So let's relate to this. Let's relate this to traditional method. 234 divided by 6. So in traditional method, you usually cover up all the place values except the highest one, and you ask yourself, can 6 go into 2? Well, no, it can't. So then you move the place value over, and you ask yourself, can 6 go into 23? What students are missing at this age is that they don't realize that it's 2 in the hundreds place and 3 in the tens place. It's really, how many times can 6 go into 230? So they're missing the value of these numbers when they go traditional method. That's why people are pushing for this new partial quotients way, because it's showing you that it can go in the amount of times it actually is. The 3 doesn't represent 3 times, it represents 30. So same for here. How many times can 6 go into 23? We would say 3. And we would put that 3 right there. But students are missing that that's not a 3. That's actually a 30. So we would continue to subtract, okay, because 6 times 3 is 18, and we would subtract that out. 13 minus 8 is 5. 1 minus 1 is 0. And then we have the method of bringing it down. But if you look over here, we have the exact same methods worked out, except we have the real value of these numbers here. It's not just a random 3. I can't explain why you would bring that number down. I can explain why you would use these place values. Okay? So that's why they're pushing more for this partial quotients method versus traditional. I teach both, so I want you to be assured that they'll have exposure to both of these methods. So then we continue on. How many times can 6 go into 54? That's 9. We subtract that out and get 0. And we're happy there too, right? Yes. And then we find our quotient of 39, which we can check again to be 234. Okay? Both methods work. It's just a new strategy that they're learning, and I hope I was able to explain why they're learning it that way.